Okay, so the last thing that we need to talk about is that, as you saw previously, there are sometimes that we try to evaluate these trig functions and we get an error or we get an undefined answer, right? So for example, if we want to get the tangent of pi over 2, tangent is sine over cosine, so 1 over 0 would be undefined, right? At the same time, if we wanted to get secant, which is 1 over cosine, 1 over 0 is undefined. Remember that cosine is x. And so this happens at pi over 2 and again at 3 pi over 2. And because this can happen as many revolutions as possible, this will always happen for tangent and secant at pi over 2, 3 pi over 2, 5 pi over 2, etc. So as you can see, it's all the odd numbers. So the odd numbers can be represented as 2n plus 1. Okay, starting at n equals, well, for all integers of n, because we have negatives. So for all integers is represented by z. For all n that are integers. Okay, and then similarly over here, whenever we are at pi and 2 pi, and we want to get the cotangent, remember cotangent is the opposite of tangent. So instead of, so it's going to be x over y. So that would be negative 1 over 0, which is undefined. Also, cosecant, which is 1 over sine, would give us an error because 1 over 0 is undefined. This happens over here at pi, and it also happens for these functions at 2 pi. And so therefore it's happening for n pi, where n is an integer. Okay, so it could be a negative, it could be a positive, okay, but for all integers, n pi. So that means at pi, 2 pi, 3 pi, 4 pi, 5 pi, negative pi, negative 2 pi, negative 3 pi, which essentially you could find a coterminal angle that's positive to it, right? Okay, so that's important. And so therefore we're going to see what happens. So we did this earlier, but if we get the tangent at 3 pi over 2, like I said, it would be y over x, which would be negative 1 over 0, which is undefined. Right? Okay, so we're going to use that, and we're going to use other information to continue our study of the unit circle and trig functions. Alright, so I'll leave that on the board. Alright, so here, let's see if we can find the secant of negative 180 degrees. Again, I might want to find a coterminal angle, so let's add one revolution of 360, and that's 180, okay? So at 180, which is pi, pick a point. Can we get the secant? Remember that secant is 1 over cosine. 1 over cosine. Well, cosine is x value, so it is 1 over negative 1. Okay, so 1 over negative 1 is just negative 1. So we got it. Okay. Alright, so now we're going to apply the period and the properties of trig functions. Alright. Okay, so here you have that a function f is periodic if f of t plus p equals f of t, where p is some constant and it's the period. Okay, so if you see these graphed, which we will graph them and take a look at them, cosine, sine, so it continues and it has a cycle, a period. Alrighty, so that's important. Okay, so all of them have a period of 2 pi. Okay, they repeat every 2 pi, except tangent and cotangent. So tangent and cotangent have a period of pi. So I'll put this over here for important stuff. Alright, so that's useful for evaluating. Okay, you'll see some examples now. And then the last thing to talk about is whether these functions are even or odd, and we have spoken about even and odd functions and the definition of them, so that's going to be useful. So all of these functions are odd. The only ones that are even is cosine and secant. Even functions. Right. So now that we've spoken about all of that, we're going to be on example 5, which is page 575. I recommend looking at the textbook in the attached to the homework, okay, especially for these sections. Okay, so this says use the properties of the trig functions to simplify. Okay, now remember, what is the definition of even? The definition of even is that there's symmetry, okay, about the y-axis. So, for example, you can see right here, if you were to plug in negative theta into cosine, you're going to get the cosine of theta, okay, by definition. So here, we can replace cosine of negative theta using the fact that it's an even function into just cosine of theta, and now we have 2 like terms, add them, and you get 5 cosine theta. Okay. For part B, we have, can you simplify tangent? Okay, now here, we know that only cosine and secant are even functions, the rest of them are odd. What does it mean to be odd? So, for example, this one right here, tangent of negative 3t, when it is an odd function, you end up getting the negative original function. I want to put negative 3t. Yeah, okay. Okay, so for example, the original function is this tangent of theta. If you plug in tangent of negative 3t, you're going to get the negative on the outside and then the original function. Okay, so we're going to replace this. Okay, so I'll do it up here. So for part B, we're going to replace tangent of negative 3t using the fact that it's an odd function as negative tangent 3t. here, we're going to use the fact that cosine and tangent both have a period of pi. So this tangent 3t plus pi is going to be the same as tangent 3t because this is the period p. Okay, so I'm going to write this as negative tangent of 3t. So what do we get? We have negative tangent 3t minus tangent 3t, negative 2 tangent 3t, and that is as simplified as possible. Okay, so this is going to be using these facts. Okay, and now we're going to do one last thing, which goes back to deriving formulas. It says that using trig functions, if you're given a real number t, express sine t in terms of cosine t. Okay, so if you're given sine, express it in terms of cosine. Okay, so remember that it all goes back to x squared plus y squared equals 1. Unit circle radius of 1. Okay, so we already know some of our trig identities. Okay, so basically it's the same. Can you solve for sine in terms of cosine? We actually did that earlier, but let's go ahead and do algebra to get this sine alone. You get sine squared x equals 1 minus cosine squared x. Opposite of squaring, square rooting, plus or minus. So sine of x is plus or minus the square root of 1 minus cosine squared x. So they give you, which we did this earlier, but not in general terms, we actually plugged in. If they give you cosine, then you can actually just square it, take it away from 1, square root it, plus or minus, and that would be your sine. Okay, and you can do this with any of the trig identities, as long as you know that x squared plus y squared equals 1, or in other words, sine x squared plus cosine x squared equals 1. Okay, so that concludes section 5.4, and we will cover the rest of the sections as we move forward. Take care.